Hey guys! So today you and I are going to talk about best practices. So let's get into it. So the question in question was, hi Frederick, what would you say are the best practices in web development? Well, that is much too big of a question for me to be able to answer in one sitting like this. I'll give you my favorite things, like the key things that I usually try to think about when I start a new project or when I'm part of a project or something, like just at the top of my head. And let's say that that is going to be some best practices. But I want you to fully understand that this is way too big for anybody to be able to just say, yeah, Frederick gave me like these concepts, and that's all I need to know. Like we're talking about, that's the whole job basically, to know all the best practices and know when to do what and so forth and so forth. But usually, the first thing I do with the project is that if it's a fresh project, it's not so much of a concern. If it is a existing project, I usually do what I call the code inventory, where basically I go through all the source code, and like, I'm not saying read all the source code, I just need to know where everything is, so I know how to deliver the software that I'm supposed to deliver into a production environment. And so when I start with a fresh project, I do basically the same thing. Just make sure that you're using something like a Git or like a version control or repository of some sort, because it is very, very, very difficult to maintain software over time if you're not doing version control. You're going to make mistakes, you're going to want to revert, you're going to be able to want to do all these sorts of things. That's usually the first hurdle for juniors. So make sure that you take some extra time to learn at least the basics of Git, because version controlling is standard practice in every single and every single serious company you will ever be part of is going to have that as a, like, you're not ever even going to be able to do your first pull request or like do your first thing in the code base if you don't have that down. And then the second thing I do is that I really try, and this is something that I underestimated a little bit in the beginning, and I still think it's a bit of a lost art form, because we still don't do it as well as I would like to in some of the projects that I work with. And that is to think about how you structure your source code. Like not how you write the code itself, but how you structure your folders and how you structure, like, the what is a good fit, like what is a good layout for your specific project. The reason why I argue that is because uh, why that is a very important best practice, to think about that, to make sure that you understand how to do it well, is because most of the times when I see a project go really, really poorly, like over a long period of time, it's usually because people don't really think about like how they structure their overall source code. And so what usually happens is that the repository becomes super, super unintuitive, like things are all over the place and so forth. This is usually the most common criticism, I would argue at the very least, for why people hate the monolith or like the monolithic application, because they associate the monolith with this sort of problem. And I argue to people that that is not really a problem with the monolith. The monolith as an application architecture is not a bad architecture. It is the fact that you are doing this that is causing it. It's a little bit, to me, like saying that, Weight Watchers or something like that, oh, going to the gym, it doesn't really work for you when you don't really put in the time. If you eat like crap all the time, yeah, you're sort of blaming something you're doing incorrectly on the solution itself. Like, and it's the same thing here. People blame the monolith for spaghetti code, when I argue that it's not the monolith that is the problem. It is the way that you are structuring your source code. One of my favorite all-time patterns to follow, and it's that perfect balance, I argue, between microservices and the monolith, is to use a modularized monolith or a segmented monolith basically. So if for to not to take the whole video to talk about that, because I have other videos about it, think about it as a repository. Some call it a monorepo. I don't necessarily like that term, because for some people that means a little bit different things. But basically, your source folder should basically just contain modules of different entities within your system, so that in theory, if you wanted to move something out of your monolithic application and make it into a microservice, you could basically just copy paste that folder, pull out an endpoints and put that into like whatever web framework you're using, right? Put that in a container somewhere and then run it, right? Or a VM. It doesn't really matter, right? That's the idea, that each module in the source folder represents your different entities, just as in domain-driven design. That is the best practice that I can, is probably, if you only take one thing away from this little talk of mine, try to do this, because it took me many years of trial and error and a lot of attempts to make, with microservice, I've done everything you can imagine when it comes to different types of web architectures, guys. And on the whole, I would say that this should be the silver bullet, should be the starting point, the default for absolutely everything. And you should only opt in for more advanced solutions when, and we can talk about that as well, because that's also a best practice, when do you split the monolith, when do you start making microservices and things like that. And that's a whole different sort of topic that becomes more complicated. But at least if you do this, you will have the simplest source code architecture you can have up until the point where you want a more complicated architecture without any real cost to it. As long as you can understand that the problem is not the monolith, the problem is when you start mixing and matching dependencies between the different modules and you don't really know how to make sure that you're not creating these spaghetti dependencies between everything. So it's a little bit of personal accountability for how you structure your source code, and that is going to do wonders. And then another best practice, which I would say seems obvious and so forth, is to make sure that you understand how to test your code efficiently. So what I usually I actually have a workshop running now with some of my not my coworkers, well they are my coworkers, but some of the developers from my company. So in my current role, I work as a principal engineer. So, and the request from the company was for me to put together an education piece basically on how to, in this case it's front-end developers, because they lack a lot of the knowledge necessary for what they're doing right now. And so I put together an exercise for them where I wanted to show them how to think about testing. So for a lot of people who do software development, testing is, you know what a test is, and about unit testing, integration testing, end-to-end testing, visual regression testing, call it whatever it might be, what you were specifically working with. The thing that people don't take the time to understand though is, when do you use one test and when do you use another one? How should you think about a good test? And so that's the thing I'm trying to teach them, that the mindset about what is an efficient test, what is a test that you can sort of skip, and what is a test that you can do manually and you don't have to automate it, for example. And so what I usually argue to people is that if you take a look at the testing pyramid, it's not a perfect representation. I argue at the very least that some people interpret the testing pyramid as if it's the way that practically you write tests, with the unit test at the bottom, and then you go higher up you go, the more less testing you're doing, right? And I argue that that is a theoretical model, but for me, that pyramid more represents how you should think about where you want to place your tests rather than what you're actually doing, where you're putting your tests. And so the way I explained it to my coworkers was that if you are writing a unit test, that brings you as close as possible to verifying, you're narrowing the scope of where if you have a risky area, if you have a feature or a function or something like that you have written where there's any chance whatsoever that you made an incorrect implementation, with a unit test you get as close as possible. You're upfront and personal with the area under test, which means that if you can express a way to make sure that that function never fails with a unit test, that's the best thing for you. Not because you have to do it that way, but because at that moment that is probably the best thing that you can do. Because if, let's say, it's for the sake of the argument, it's a pure function, then it's a perfect situation to use a unit test, because there's no external dependencies, there's nothing that you get. It's the cheapest way for you basically to figure out where the error is in your code, if you can fix it that way. And that is very powerful, because as I like to tell the front-end developers, when we go and look at their UIs and then we look at their testing strategy, and I say, if I click that buy button there, how do you know it's working? And they go, well, yeah, because there's going to be an error if it doesn't work. Okay, cool. What would you think? How fast would you be able to figure out what went wrong? Because if the only way you can figure out that something is wrong is by me clicking the button, well, then you're basically saying that the user or someone who's testing it might have to click it, and then are you 100% sure that you can track down where the error is? If there's no stack trace or anything like that, how are you going to figure it out? And that's the power of understanding what type of test to write and why you do it in a layering fashion. Because if something goes wrong and you have a unit test for it, it's very easy to narrow down and to figure out where the error is, because you're so close to the implementation that it's basically impossible. Your scope is very, very narrow. The higher up the pyramid you go, the harder it gets. So if you skip a bunch of like layers of testing between, your manual test at the top and your unit test, it can get really tricky for you to narrow down where the error is. And so that's the thing I try to teach people when I do these workshops, that, I'm going to let, like in this case, this scenario is they get an application that I made, very simple application, nothing fancy whatsoever. I made my own implementation the way I would have tested it, and then they get to try it out. They get to pick any testing strategy they want. They can do whatever you want. Prove to me and the others that you have tested this application. They have some bugs and things like that, and feature requests for the application that they implement, right? And then just write tests for it. Prove to me that you have tested this and you feel confident that if I ship this to production, it's gonna work. And even if there's 6 months, I know that these features that I've locked down with my testing strategy are going to work. That's a really good investment for you, to learn the different types of tests that you write, and to start to think about, okay, for say a UI component, well then maybe a unit test might not be enough in of itself, because in a UI world you have CSS and visual elements and stuff like that. So you might need a unit test for like the clicking or like the interactions with the component, and a visual regression test like a pixel diff or something like that shows you if, let's say, the alignment goes weird, or like say a font becomes incorrect or something like that. And for us backend developers, maybe you're writing a unit test and then mocking everything might not be enough. Maybe you might have to make sure that you have at least one test that makes sure that your models are being serialized correctly into the right structure in the database, and it's getting stored in the right schema and things like that. That's the thing I want people, like, that's a really good practice to learn that. Like, don't think about just writing a test as, okay, this is a test that tests a part. Think about what you want to make sure is working, because the test is a tool for you to figure out if it is working, but you have to understand which test would be appropriate to answer that question. So what I want you to take away from this is that, at the top of my head, to not take this video because it could be like hours basically, I would say that my top 3 things is usually: number 1, make sure that you understand version controls, and you make sure that you understand the importance of taking good care of your versions of your code and so forth, apart from like all the web stuff and so forth and so forth. Number 2 would be make sure that which is tied into that basically, make sure that you understand good source code structure. In other words, not how you write your code or your business logic, like how you structure your repository. My personal favorite is a monolith application to start off with, even for larger projects, as long as you understand how to modularize things. Like a good pattern that I like to reference is the kernel pattern. For if you look at, say, the Linux kernel or something like that, you have an aggregate, like an entry point into your program, or like a kernel, and then you have modules that you can attach to that. In a backend world, that's basically, you have the server call, like your web framework usually has a run function, or like something that starts the application server, and then you have a bunch of controls with endpoints. Think of it this way: every source folder with a module just exposes a controller that has all those endpoints with all the business logic that necessary, like in the same folder, and then you just import that into one single entry point file, which is your server starting up, and that just loads up all the controls. If you remove a controller, those endpoints are no longer there, but you could move that into a microservice whenever you want. If you follow that structure, it's going to help you a lot with maintainability over time. And then finally, make sure that you don't just learn how to write tests like in your frameworks and stuff like that. Learn how to write the right test to test the thing you're interested in, because I promise you guys, I've seen more than a few companies and teams where people, like, they have written some tests, but they don't trust the tests, because the tests aren't really making sure, like, they're not giving you an assurance that things are working. And that's a pointless test. If you wrote a test and it doesn't tell you if something went wrong with the thing that shouldn't be going wrong, then just skip the tests. try to figure out which, like, of all the different ways you can test your code, which method would be best for that specific part of the system. Have a great day.